Hey everyone, welcome back to my channel EduVibe. In today's lesson, we are doing the last topic of the atomic physics, which is the fundamental forces and the Standard Model. This is not a topic, but we just review all the fundamental forces and do some the topic called the fundamental model, and we end this unit. After we do some practice question of that part, then we do some diploma questions, then we end this unit. So, we just summarized this thing in the previous lesson, I think. That below summarizes the fundamental forces or the attraction of the universe along with their age and their distances. We have attraction, range, and their strength. So these are the main four forces we involve. We discuss these forces throughout this course, throughout the whole 4 units, and this is the 4th unit. So we have total of the 4 things, but the fifth one is the Einstein theory. So we have to just go through with that thing to know more about this. So in the electromagnetic retraction acts on any particle that has an electric charge. You know that. For our purposes, the attraction is governed by the Coulomb's law, but we remember this is only for the stationary point charges and has an infinite range. And it has an infinite range over there, you can see. So this is about the electromagnetic attraction, which is like attracted by the electric charge. Weak nuclear attraction acts on protons, neutrons, electrons, and neutrinos in order to bring the beta decay through a conservation of quarks, U to D, D to U in the beta negative decay, U to D in beta positive decay. The force has been the extremely short range along a few femtometers, which is 10 raised to minus 18 meters. And we discussed this topic also in the previous lesson when we do the D to U beta negative decay, U to D in the beta positive decay. Then we are moving to the strong nuclear force attraction acts on protons and neutrons only. We discussed that topic during the particle zoo topic. Keep them bound to each other inside the nuclei. This force has a short range around 1 femtometers. It has the strongest of the 4 attractions. This is the like a very strong nuclear attraction. That's why it is a very strongest of the 4 of the attractions. The gravitational attraction is the force of attraction between the masses. So gravitational attraction is also the force of attraction of masses, we know that. And this is the third one. In physics 20, this is what described by the Newton's law of universal gravitation. We do a gravitation part more in the physics 20. We don't do we just do the something we involve in that gravity. We don't discuss that gravitation up in this course or in the any unit of that. But it's not a complete picture of our understanding of gravity. But this is not the gravity we can discuss. We discuss the gravity more in the higher studies. So these are the main 4 things, main 4 fundamental forces. But you have a fifth one, which is the Albert Einstein theory of the general relativity, gives us the understanding of the gravitational attraction to date. However, unless we are dealing with objects that have extremely large gravitational field attraction, Newton's law of universal gravity gives the excellent approximations. That all you discuss in the higher studies, not for now. And these are the 4 fundamental forces. These 4 only, not the NSI's one. So this is just overview of that and some overview of the Standard Model. So to build a life, we need the DNA. We need a DNA. To build a DNA, we need some nucleobases that you will already study in your Bio 20 class. All these things, that AGCT. In physics, everything is made of the particles. Some of the particles are made of the fundamental particles, no quarks, which cannot be broken down any further. The physics says that all these things can be made with particles. Some with fundamental particles, no with the cross, and cannot be broken with any further. The building blocks of those fundamental particles in physics is known as a Standard Model. We name this as a Standard Model when we build in the blocks of the fundamental particles in physics. For present time, the Standard Model is our best understanding of the theoretical framework of particle physics. For a particle physics, the Standard Model is a very good thing and very good understanding of the theoretical things. It has been very successful in accounting for most of our observation, though it's not complete. As you may have noticed, one of the 4 fundamental forces not accounted for in a Standard Model, which is gravity. But these are not involved in the gravity thing. Gravity is a separate thing, we can say. And from the conclusion, from that the DNA part or some particle physics part, we conclude that physics is the science of the life, not a biology. So this is all the thing. This is some of the theory gave by some scientists about that the DNA and the particles of the DNA to build the particles to build the DNA, some nuclear bases which we use are made of particles and some other fundamental particles which is involved in the physics. That's why they conclude that the physics is the science of life, not the biology. And this is something about the fundamental standard model of the elementary particles. So that's all. We give some overview of this thing. And to just know about the fundamental forces and standard model, not like conclusion part. This is a topic which gathers all the things we discuss in this course. And this was the end of this unit, and we all doing that. All explanation has been done from this unit and from the every previous unit. Now we are doing some practice questions of this part. Then we move on to diploma questions. Then we officially complete this course. So for now, learning us by EduVibe, learn smart not harder. Please like and subscribe to my channel. If you have any questions, let me in the comment section. See you in the next lesson. Till us with EduVibe.